Mic check. All right. Now, if you have exhausted all your methods, so if I don't really know how to factorize it and I really can't be bothered to complete the square, or I'm looking at completing the square and there's a bunch of fractions, or the question hasn't told me to complete the square and I don't really feel like it, or the question hasn't told me to factorize, it's just told me to solve this thing, but I can't think of two numbers that add to this and times this, or I can't be bothered doing the a times c plus b because it's too much working out and I don't know for sure that I can even factorize this thing, then what you would do is you'd use the quadratic formula. So there's a formula that basically does this for you. It comes from completing the square of this. So if anyone was game enough to be able to do that, there's actually a scaffold for it underneath the exercise, but essentially what they do is they get this and complete the square. So they go like, they divide everything by a, so b on a, and then they halve it and square it, and they do the whole thing. Then they solve it for x, and what they end up with is x equals plus or minus, no it isn't, minus b plus or minus the square root of b squared minus 4ac all on 2a. A couple of things you can take just from the formula itself. One, a can't equal 0. So I'm going to write that. A cannot equal 0. There's two reasons why a can't equal 0. One is because this would destroy itself. So if this was 0, then you can't divide by 0. But the second thing is, if a was 0 in the first place, so if this was 0, that means this whole thing would be 0. That means it wouldn't even be a quadratic in the first place. So it wouldn't even have a power 2. So how can I use a quadratic formula on something that isn't quadratic? So that's basically why a can't equal 0. There's a second thing, and it's that this thing in here can't be less than 0. If it is less than 0, that means there aren't any x values for which this is true. So that means, let's suppose I've got some equation and I'm trying to solve it, and I can't solve it, which means I'm going to end up with a negative square root or something. That's going to end up in here. So if you're ever trying to solve one of these, then you end up with a negative in here. That means there isn't any solutions. That means I can't put anything in here that is going to make it, that's going to satisfy the equation. Okay, so now that we've got all that out of the way, I'm going to do the same example 3 times using each of our methods. So our example is going to be x squared plus 5x plus 6 equals 0. Now, method 1 is factorizing. So I can factorize this. So that's going to be what adds to 5 and times to 6. Well, 2 and 3 add to 5, and 2 times 3 is 6. So x plus 2, x plus 3 equals 0. So that means x plus 2 equals 0, or x plus 3 equals 0. That means x equals minus 2, and x equals minus 3. So if you're asked to solve this, and you can identify that it can be quickly factorized, do it, because that was pretty easy. Second thing I'm going to do is our second method, and that was completing the square. Complete square. So what do? I go x squared plus 5x. Let me just write the question. I'll move the 6 over, and then I halve it and square it. So I halve it and square it, and I add that to both sides. Okay, so now I can factorize this thing. That's x plus, so I've done this a bit of a different way. Now minus 6, I'm going to need a calculator for that thing. Minus 6 plus 5 on 2 squared is a quarter. Cool. This will be embarrassing if it doesn't work. X plus 5 on 2 equals the plus or minus the square root of 1 on 4. X equals, now, the square root of 1 on 4, that's the same as the square root of 1 over the square root of 4. Square root of 4 is 2. So that's really plus or minus a half minus 5 on 2. Now, let's go with our 2 cases. Whoa. Oh, Jesus, okay. Now, either x equals a half minus 5 on 2, or it equals minus a half minus 5 on 2. So I've just written this and this here and here. Let's do this left one. So a half minus 5 on 2. So that's going to be minus 4 on 2, which is minus 2. This one, minus a half, minus 5 on 2, that's minus 6 on 2, which is minus 3. And look at that, I've ended up with the same solutions two different ways. Now let's verify all of that with the quadratic formula. Now, I just need to work out my coefficients. So A is going to be equal to, so remember it's just A, B, C. So A is equal to 1, B is equal to 5, and C is equal to 6. So it's the same A, B, C that we used in this factorizing. So the same A, B, C. Now I'm going to write the quadratic formula. So x equals minus b, plus or minus the square root of b squared minus 4 times a times c, all on 2a. Okay, now I'm just going to fill it in. So minus b, that's minus 5, plus or minus the square root of 5 squared minus 4 times 1 times 6, all on, so literally just substituting into this, 2 times 1. Now, this is why the quadratic formula is a little bit gross, because if you're not got nice numbers, then it's going to get kind of disgusting. So I guess if you ended up with a square root here that isn't a square number, then it's going to get kind of weird. So that's why you kind of try and stay away from the quadratic formula, but at the end of the day, it always works. So now I've got 25 minus 24. See, this is a nice number. It's a 2 on the bottom. I know it's a nice number because I know what the answer is. We've worked it out twice already. Okay, that means I've got minus 5 plus or minus the square root of 1 on 2. Okay, the square root of 1 is 1, so minus 5 plus or minus 1 on 2. Okay, so that means x is equal to minus 5 plus 1 on 2, or minus 5 minus 1 on 2. Minus 5 plus 1 is minus 4. Minus 4 on 2 is equal to minus 2. This one, minus 5 minus 1 is minus 6 on 2, which is also minus 3. So I've gotten the same thing 3 times using my 3 different methods, and you can decide which one is the most efficient. But let's actually label this one quadratic formula. So essentially all I want you to be able to do is use the quadratic formula to solve any quadratic. But again, just go through your checklist. Like if I'm looking at this and I can factorize it, then factorize it. And if you can't factorize it, but all the numbers are kind of small, and if I halve that and square it, then it's going to be a nice number, then you might as well just complete the square quickly. But if you've exhausted all your options, then use the quadratic formula. So the exercise is going to say use the quadratic formula, but I want you to just try and be smart about it. Like if you don't have to, don't. At the end of the day, you're not like the whole point of this is that we're trying to solve a quadratic equation. You shouldn't have to be told what to use. But a question might say, complete the square, please, and you'll be like, okay, fine. But just do whatever you want, whatever you think is the most efficient. But just recognize that a lot of things you can't factorize. A lot of things are going to be really gross to complete the square with, like, for instance, some of the examples, like this example, that was kind of gross to complete the square with, but at the end of the day, we could have done it. Well, we did do it. We just couldn't factorize it. So please try and use the method that is most appropriate. And if you're game enough, try and complete the square on this and end up with that. Yeah, that's it.